how to get the results to the real world.
Thank you for the opportunity to briefly touch upon some issues that we've encountered. We've heard all the technical details from Rick in the previous talk, and what Rick's working on is going to be incorporated into our next generation fetal monitoring technology. So that's why I believe that the future of fetal monitoring starts now. Let's see if this works. About Nemo, we consider ourselves a leading developer in fetal monitoring technology. We were founded in 2010 as the result of the cooperation between Eindhoven University of Technology and Maxima Medical Center in Veldhoven. And that's also where we are located. The building that you see is a wing of the hospital. So we're close to the researchers that we cooperate with. We're a small company, so our production is outsourced to local partners who have ISO 13485, which is necessary for production of medical devices. And we do have quite a relevant network with important doctors in the world who are helping and discussing with us about the options for this technology. If we take a look at what's happening in the past 100 years, past centuries, that we see that there's becoming more information available in earlier stages of the development of the fetus, and that's what's going on. And the introduction of STAN brought something, and I believe that fetal ECG, which has been developed over the past 10 years, is going to be the next step. This is something that we all know. Traditional fetal monitoring fails. The invasive alternatives that can be used may sometimes end up in dramatic results. The tracing that Rick showed in his presentation about the placenta being punctured, that's the one that you see here. So, and this is something that I think we all believe in. Electrophysiological monitoring will hold the future because where ultrasound is developed to its full max, non-invasive electrophysiological recordings open up a new field. So I think we can take off there. The question is this: it's about reliable information. So far I've heard a lot of important talks with a lot of interesting results. These are all relatively small experiments in labs, but what we need is reliable technology that works with every operator. It works on every patient, black skin, white skin. It has to work in every clinic, in the United States, in Africa, and it has to work in every climate condition. We've experienced that when you do measurements at 1 kilometer height in a dry area, it influences how you prepare the skin, abrade the skin, and get your results into your system. As the people from Monica will know, if you have an electrophysiological recording, if the recording is bad, your system can't make it better. So you have to have clean signals. I think that's very important. So the discussion is not only about the performance that we're looking for, but it's also about the users. We have what we call in Dutch tile wisdoms. So it's a saying, and this is one I think is appropriate. I believe that things only become an innovation once they're truly implemented into day-to-day practice. And if that hasn't been achieved, then it's merely a good idea. So I think we should be focusing on how can we implement our technology. And this is a reality check from users that we've experienced in the past, and I no doubt can ask my fellow colleagues from different companies, they've experienced the same. What we've seen with our technology is that people are very reluctant in trying to adapt to new technology. They don't want to change. They don't want to learn new things because it takes time, and they don't have time. There's a lot of pressure on the different departments. And there's this important thing about perception. We consider our technology to be non-invasive. We put electrodes on the abdominal skin of the pregnant woman.
And what we need to do to get a good signal is abrade the skin lightly. I've had nurses telling me that they think my technology is invasive because of abrading the skin. And they think my patient doesn't like it, so they don't like to use it. So we can discuss about the options of fetal monitoring, non-invasively recorded signals. But if the nurse thinks it's invasive technology, then you have a real problem. And you need to overcome that. And what we see with introduction of novel technologies is that you see a shift in cost. In the Dutch healthcare system, we provide technology to clinicians. They have to purchase it, and this is a rise in their expenditure on an annual basis. And we may reduce on C-sections, which is good, which is, however, a saving downstream. And actually, for the hospital, the incentive is not very good, because they get more money for C-sections than they do for vaginal deliveries. So, introduction of your novel technology also has to consider the reimbursement issues that we're facing. To give you an example of what I've actually experienced in discussing with gynecologists, you see one of the tracings here from the W3 trial that Rick discussed about, where we compared EHG, which is pure trace, the middle, this one, simultaneously to IUPC and to TOCO registration. And as you can see, our registration is much better than the TOCO. And in day-to-day practice, people don't get to see 2 simultaneous recordings. Now they see 3, and they're not telling me, hey, this is better than my TOCO that I have in 90% of the cases. Why do you have this while my IUPC doesn't show that? And I know in the United States there's a big discussion going on about counting the contractions. There would be 5 contractions counted here, according to US clinicians that I spoke to. And here they would maybe count 7. 1, 2, 3, 4, 5, 6, 7. And that's a challenge that we need to overcome. I believe that the technology is there. I think that EHG is actually capable of providing more information in earlier stages, and it allows you to better see what's going on. But we might need to redefine how contractions are, what contractions actually are. For your information, BMI 37. This is another recording with our system, also from the W3 trial. You see again, much better registration than TOCO. You see something happening over there where your IUPC also shows something. The problem is everyone accepts this from the IUPC and no one doesn't accept this from EHG yet. So why do we believe this is going to be successful now? If you consider the technology that we have that has progressed over the past decades, the processing power has increased enormously. Battery lifetime is finally up to speed in a sense that you can actually monitor complete deliveries for 10, 12, 14, 16 hours. When we started with our first technology, we made it wired. That was in 2010. Why did we do wired technologies? Because wireless was still not an issue in the delivery room. People would go for certainty, and a wired connection is certainty. This has changed over the past 3, 4, 5 years, especially with Philips introducing the CL system, where they have wireless TOCO transducers. We believe that wireless is going to be of good enough capabilities to actually provide your data now. And an important thing that we need to work on is electrode technology. Wet gel electrodes are current state of art, but I can imagine that in the near future, say 3 to 5 years, maybe 10 years, we will have contactless electrodes that can be woven into your clothing, and then you would have your continuous monitoring system available. Also, the market has changed. Patient comfort is more of an issue now, and providing wireless patch technology that's not invasive is a big plus compared to sensors that are strapped around your waist or invasive sensors. we see that there's less personnel available. So if you have good technology that can support them, that they don't have to place again, that will help in adoption of technology. And I think the competition increases between companies, but also between hospitals. People are looking for non-invasive alternatives to provide the best possible care to their patients. And that was different 10 years ago. So that's why I believe that the market is ready for adoption of this kind of technology. What we need to keep in mind is that we are discussing about different kind of modalities and biomarkers that can be presented, but please be aware that there's an existing infrastructure, and that existing infrastructure currently is capable of showing tracings of contractions and fetal heart rate and maternal heart rate. All the other things that we discussed about are currently not presented to your clinicians. So if you're developing technology, think about how to present it to the end user and how it matches with the existing infrastructure that's available. And very important for accepting this technology is that we have to educate our people. We have to tell them over and over again that electrophysiology is going to be the future. And we need you to spread that word as well within your clinics. So make this fun. Some of the results from our current device. What you see here is a comparison between non-invasive recorded fetal heart rate and scalp electrode at 37 weeks. And you see that it's matched perfectly. Sometimes we can experience some signal loss, as can your scalp electrode or your Doppler ultrasound can, as is shown here, where the pink is our signal and blue is Doppler ultrasound. So all in all, I think with the progress, the technical progress that we've made, the time's ready for the future of fetal monitoring. Thank you for your attention.
Thank you. So, any questions?
Could you come with the slides, please?
Yes, indeed.
This one. You're saying that you have filters and the number of transactions wouldn't match the IUPC. But I think that the way you go to filters, so that's an energy coming from the HT signal, right?
Yes.
That's also a problem because you don't get different places using different algorithms. You are working on an EHT signal itself, so you are getting the energy. You can get different shape waveform using a different algorithm. So the question is, what is the best algorithm? So you would probably, if you would use another algorithm, you would match the IUPC contractions.
Yeah, well, we're currently constantly improving also these algorithms, but you need to keep in mind that when you produce a medical device, you have to create a file, and this file needs comparison data. So we've compared our algorithm to IUPC and to TOCO, and this has been submitted. Changing my algorithm in my hardware requires a change of my notified bodies and renewed CE marking or FDA clearance. So it's not just a matter of let's change the algorithm and do this again, because it's the heart of my system, which is considered a significant change to the technical file.
You're saying that it's validated that algorithm?
Yes, we validated against IUPC. More questions?
Can I? Oh.
Let it go first.
I was going to do an encouraging comment because I didn't like the tone of our previous talk. I'm a great believer of the transabdominal monitoring, and I think contractions is the first step. And I think it's great that I've been monitoring what's going on. So I just wanted to say a big thumbs up.
Yeah.
I know it's hard, and you need. You just Yeah, just keep on being creative, look for new strategies to try to introduce it to clinical practice, and I'm looking forward to what Austin wanted to say, because I assume you are very supportive as well, right?
Oh, absolutely.
Absolutely, it's just, everything is so slow, and
I
yeah,
know.
it's just,
I know.
it will happen, yeah. So I just wanted to say, great.
Yeah, on top of that, I'm just going to draw your attention to what I think is a minor but important wrinkle, which is this. If you go to the United States, they will monitor babies, running their stream at 3 centimeters per minute. In the UK, it's 1 centimeter per minute. I still can't understand why the Dutch insists on 3 centimeters. Is it to confuse an already complicated atmosphere? And the more important point is, it's going to translate to more difficulty and complexity when it comes to comparing results of people trying to replicate your ideas and all of this. And I think it's a small point, but I think it's an important point.
Yeah, well, right now you see that the technology interfaces will be existing monitors, so
You've got no problem to display it in any. You can display 5 centimeters a minute. That's no problem. It's a computer algorithm. Just what is your printing technology, or you on a screen you can display whatever you want. You can do 3 of them if you want.
Well, one of the things I think is also important from your presentation is the fact that you make the point that it has to be idiot-proof.
yes,
It has to be used at every setting by everybody,
Yes.
every user.
that's a message that I want to bring.
Exactly. And the simpler you make it, the more homogeneous it is,
Yeah,
the more likely you are to achieve our objective.
yes. That people have to keep that in mind.
45 years ago, I asked the question, why is it 1 centimeter in here, and why is it 3 centimeters in the United States? And I was told it's because the most expensive part of a monitor over time is the aftermarket cost of the paper. And in the United States, they use more paper, and that was more money for the manufacturers of the equipment.
But let me just enough with these centimeters per paper. We are in a different era now. We have touch screens and so on. Just don't forget about centimeters per minute. Soon we'll be fully paperless. You can have a screen on the wall if you.
But
No,
it
I mean
projects,
that's
projects
it with
a
paper.
picture. You're used to looking at a picture.
Yes.
You
My
can-
colleague next to me and myself realized that I thought I was looking at tracings. I was doing visual reading of tracings. And for the longest time on screen, they were 1 centimeter per minute. And I had assumed it was 3. I was very confused by the shape of what I was thinking, never thinking that it was 1. And then when we got it, we made it 3 centimeters per minute. I personally saw more information in the tracing than I would have thought, but that's my prejudice. But it is different.
Okay,
Part of
but
it, when we first started with fetal monitoring, we had no screens, and all we had was the paper. What you did is, this is 6 feet is an hour, you spread it this way, and we used to do floor exercises, that is, throw the tracing from there
I know.
to there. But there was a lesson to be learned in the evolution of the pattern, which is lost if you only have, and you don't go back and review it.
But you can
So-
show trends and everything at the moment with the
No,
computer.
absolutely.
It's
Now,
no
the question
problem
is,
to
what's
summarize
important?
it. You can just zoom it. Even think about your Google Maps. Think about how you just do this with fingers. You can do that with CTGs, no problem.
Right, but
It's
there
English.
probably is some merit, for example, to the dual display of here's the 10 minutes and here's the last 4 hours
Mhm.
with
Probably, yes.
with alerts and things like that.
so
You might
thank
as well.
you,
Yeah,
thank you,
take
Bas.